Coming up next is my good friend Catherine Winkler. Catherine's going to be leading a panel to address Data Center 2025. I'm going to stop talking now and welcome Catherine and her team up to the stage. Thanks, Catherine.
Good morning. Michelle, has the conference started yet? Good morning. Good morning. Thank you. Thank you. I am very honored to be here this morning. First and foremost, I want to thank all of you who came to the conference. We learn when we bring our minds together and our experiences together, so thank you for giving me the opportunity to learn from you. So my name is Catherine Winkler. I am the Chief Sustainability Officer for EMC Corporation. I also have the pleasure of being a director of the Green Grid and Secretary of the Green Grid. Now, sustainability, which John mentioned earlier today, I'd like to think of it really as recognizing that the decisions that we make today are what's going to decide the options that we have in the future. That's true in our personal lives, it's true in our countries, it's true in the world, it's certainly true professionally. So even though each and every one of you has decisions that you have to make, thousands of them every single day, somewhere you need to be considering what is it going to mean for the organization that you're part of in 10 years, in 15 years. So we're very lucky to have with us a tremendous panel. I'm going to let them introduce themselves in a minute, but let me just briefly mention we have Scott Hannaberry from Schneider Electric. Scott's going to, we hope, give us some insight into whether smart grids and data centers are going to collaborate, converge, collide, maybe, conflict, all of the above. We have Vernon Turner from IDC. Vernon is going to tell us how much 35 zettabytes really weighs. I know you think data doesn't weigh anything, but when there's that much, it really does start to put some weight on your data center. We have Steve Doig from the Rocky Mountain Institute. Steve is going to give us some insight about what's happening with facilities. Are they even going to look like something we recognize down the road? We have Mark Agar from Microsoft. Mark is going to do a little jujitsu on the first law of thermodynamics and figure out how we're going to convert data into fuel, right?
Hey.
And
let me start on that.
last but not least, we have Mr. Jim Smith from Digital Realty Trust. And I'm hoping Jim is going to let us know whether he believes a word of what us vendors and analysts are actually telling him, because Jim is the practitioner on the panel. In a moment, I'm going to ask them to introduce themselves and maybe give us a word or a sentence or two about what you do, why you care about the future of the data center, and why the people in the audience here should actually care about the future of the data center in 2025. But first, let's find out a little bit about who the audience is. So how many of you would classify yourself as end users? Okay. Ooh, not that big. And how many of that would you call yourselves facilities people? Okay, a lot of facilities in the back. Interesting. I wonder what that says about facilities people. Okay. How about IT systems folks? All clustered in the middle. There's something going on here. All right. Vendors? Quite a few vendors. Okay, so maybe we do have to speak to the vendors a little bit. How about consultants? Government? There's somebody. Academia? Okay, nonprofits. Okay, am I missing anybody? All right, so now you have a sense of the audience. So who would like to start with an introduction?
Why don't I go? All right, so my name's Mark Agar. I work at Microsoft in our environmental sustainability team. I've been in that team for about 4 years, and I focus on both what I call greener IT, because recognizing that it's a journey, not necessarily a destination. And then also the other side of the coin, IT for green, or as I like to call it, sustainability through software. So I sort of spend probably about half and half on that, although I actually own greener IT inside Microsoft.
And these folks should care about the future?
Oh, yes. So why should you care about the future? Well, because it's coming tomorrow. so I think, the one thing that we probably care about, I think the Green Grid's doing a really good job to make sure that we don't get regulated out of existence. I don't know how many of you saw the post by the EU Commissioner Nellie Kroes, I think how you say her name. She has been very concerned about the growth of data centers and the amount of energy they use. And so that's just one aspect. I think obviously the sustainability factors are another, just for our own sake, and back to the regulation again. And then technology is changing and evolving, and ultimately becomes a competitive issue. How much of your bottom line do you want to sink into IT versus actually making money and reinvesting it into something even more useful. So.
Thanks. Stephen?
Hi, I'm Stephen Doig from Rocky Mountain Institute. I've been there about 5 years now, and I lead research and collaboration there, where we both do our own research, but then work with for-profit and companies and institutions, public institutions, to help them solve resource and efficiency problems. We actually got interested in data centers about 11 years ago. We published a book at that time showing that we thought at the time that you could dramatically reduce the amount of energy required for per unit of compute, let's say, or service to your customers. What's been interesting since then, that book is reasonably clairvoyant, is that there has been dramatic drops in the amount of energy required per unit of service, and we did a lot of work in the mid-2000s on that as well. But now the reason why I'm here today, and we still have an avid interest in this, even though the industry has taken the bull by the horns, as part represented by the Green Grid, is that we see a real nexus of use of IT and data, whether that's in controlling power plants and renewable energy resources, talking to smart cars that are basically EVs, electric vehicles that are powered by the grid, appliances in your home that will become smart and be talking to the grid all the time in terms of demand management. And so we see an enormous explosion in the use of IT and data centers in particular to control all things that have to do with energy and energy efficiency. And so it's actually an increasing challenge to bring that technology to bear and make sure it doesn't become a burden at the same time.
Good afternoon, good morning, everybody, and congratulations to the Green Grid for 5 years. Tremendous effort. My name is Vernon Turner. I'm the Senior Vice President for Research at IDC, and I've been there about 13 years. And the last 5 years, we've dedicated a fair amount of effort and time to supporting initiatives, say, driven by the EPA to create the Energy Star programs for data centers and servers. So we're the guys behind the numbers, as we often get labeled, but really do a lot more deeper dive stuff than that. I've been through the wars. I've been a systems programmer. I've been a capacity planner. I've built data centers. I've upgraded data centers and watched water come into them, which is not a good thing when you've got a lot of electricity. And I've moved data centers around the world, particularly in places like Boston, when you have things like the Big Dig, and you don't want a backhoe going through cables. So I've seen a lot of stuff happen, but what really is fascinating right now as a researcher, and Catherine's asked, why would I care about this? I can openly and honestly tell you, we are at the cusp of a change that we have never seen before. In the 30 years I've been in the industry, the collection or the coming together of big data, mobile, cloud, and social enterprise is going to make us think, really, really think hard of what a data center looks like by 2015. And by 2025, I don't think any of us is necessarily going to understand or realize all the good work you've done today to make that economy driven by the internet be sustainable. So I'm fascinated by this. We are just about to enter this new era. So I'll hand off.
Good morning. I'm Scott Henneberry with Schneider Electric. As opposed to John and most of the other Schneider people you've ever met, I am not in the IT business. I'm sort of a power guy by background. So when I think of the word network, I think of power lines and Kirchhoff's law and stuff like that. I do have quite a bit of software and control in my background, and of course the one common definition of the smart grid that's pretty general is the intersection of the power and the IT network. So it's wonderful to have been invited to speak here today. In terms of why should you care about the future in that context, I think it's fairly self-evident, to be honest. But, you know, Wayne Gretzky once famously said that the one attribute that he has that differentiates him from other hockey players is that he doesn't skate to where the puck is. He skates to where the puck is going to be. And his ability to see that is what is different about him. So if, you know, in the data center industry, you don't believe that there's any dynamics in technology or commerce or business model that's going to be dramatically affecting you in the next 25 years, then you don't have to worry about the future. And I hope you've done a good job managing your retirement funds. But if you do think that there's some dramatic changes, dynamics that are happening, then it's, of course, important to try and figure out what those are and to try and skate to where the puck is going to be.
What was the question again?
Who are you and why do we care?
Why is it important in 2025? My name's Jim Smith. I'm the Chief Technology Officer and the Head of Design and Construction for Digital Realty Trust. And so from my chair, I build a lot. Now that we've grown as a company, we also own a lot. And so we, I think, represent an important view of a steady state type of business. 5 years ago when the Green Grid first got going and I was involved, you know, the new data centers were the big story for us, right, for us as a business. Now that we've grown, we have this portfolio, and the future is not a discrete point in time, it's a continuous flow for us. And so I think one of the viewpoints that I can bring is, and why I think things are important is, data centers are very persistent objects. They're big, expensive, physical capital assets with mass and presence. And for as much as we talk about what's happening today and what we're going to do on the battlefield tomorrow, so to speak, what we do today is going to last. You know, it's 2025 is 13 years. 13 years ago was 1999. In my portfolio, we have a huge set of data centers that were built in 1999, and they're running very well. They're keeping customers up, and those clients are doing their business. I expect those to last for another 13 to 15 years before we really have to do a full forklift refresh. And even in that scenario, my expectation is we probably won't refresh the whole kit, right? The power disconnects and some of the cooling plant and the piping will be there forever, fundamentally forever in our business lives. I think that's one of the important things about looking ahead is that combination of the persistence and that flow of what we're doing, because it's so easy to talk about the latest thing and the new thing, and that's obviously where we all need to be and want to be. But what we do and leave behind in any given build or any given operational profile is something that's going to be around for a much longer time than most people give credit to today. So I think that should be part of the discussion, is this aging and life cycle of the things that we do today. And I think I learned something from John Pfluger about servers, which was there's a point in a server's life cycle where it becomes more economic to replace it. I presume the same thing will happen to buildings and data centers, but I think that point is going to have to be a lot more radical because the data centers are thousands of times more expensive. And very early in one of the very first Green Grid meetings, somebody, I can't remember who from HP, presented ranking PUE as a way to decide which data center to consolidate. And that was a very innovative use of that metric. But I think now, as we've gotten closer and closer to kind of better performance, it's going to be a lot harder to discard something that's not perfectly efficient if it's holding a position on your balance sheet, generating some revenue, and keeping customers happy. So I think this idea that there's an edge and a change that's going to happen overnight is tempered by the fact and the reality of the economics and the physicality of the data centers themselves.
Okay, thank you, gentlemen. So I have a question I'd like at least a couple of you to take on. And while I'm asking and they're talking, some of you think about questions that you might have, because we're going to open it up to the audience before the end. We'd love to get you engaged. So, you know, I come from a company that's very invested in cloud computing. We see that as the transformation that the industry is having now. And with cloud computing, if it meets its promise of decoupling the computes and the data from the underlying physical infrastructure, so it can move from server to server, geography to geography. In some sense, it makes data center walls porous. If that's true, is the data center really going to matter? And if it does matter, what's going to happen? Is it going to be one big data center in Iceland? Or is it going to be a lot of little data centers in our garages? Or is it just going to be, Jim, the same data centers we have today because they still haven't hit that magic inflection point? Who wants to take that on?
I'll start on that. We have a few data centers, last time I checked, running clouds. So, I think, I've been at Microsoft for 12 odd years now, and I started in the Windows Server team, and it was very odd to me at the time when we were building something called small business server. It's like, why would a small business want a server? It seems kind of insane that you would want something else to manage rather than actually, running your business. And at the time, we really didn't have the sort of the technological infrastructure to allow you to, host that server remotely. But the world has moved on, and bandwidth is a lot more available than it was today. And frankly, if you don't see IT as core to the mission of your business, then you shouldn't have a data center. You shouldn't have servers. The only thing that you should have maybe are black boxes that cache data for you just to make it faster to access than directly over the internet. But so I think there's going to be a lot of the long tail that will find it very cost effective to move into the cloud. But there's going to be a lot of still large data centers for folks that really view IT as a competitive edge for them. But the other thing to think about, though, is that data center going to be large physically, or is it going to be large virtually? I would contend that with the ability of software and the amount of bandwidth that we have, especially the amount of dark fiber that lies around, that you could actually distribute that data center around the country and actually put that compute and storage closer to where it's needed, closer to the end users, and actually manage the thing virtually. You could encrypt the data so that even if it's not sort of within your physical protection, you can be assured that if somebody tampers with it, then they aren't going to get access to the data. So and one there's a trade-off in terms of where you distribute it. One is you can think about distributing the data to the end users so that you have better access. The other thing is you can think about moving the compute actually closer to where the power is, and actually just shipping the data to the actual end user. Therefore, you don't actually incur all the losses.
You could ship the end user.
You could ship the end user. That probably wouldn't be so popular, especially if you're shipping them to a wind turbine in the Dakotas. But talking to wind turbines in the Dakotas, I mean, sticking a container right underneath the wind turbine and just shipping the data as power to the end user, I think will be very attractive for certain scenarios. So I think we're going to see the data center as an entity change over time as people become more comfortable with remotely managing it.
So Vernon,
I would agree that there's still going to be a long history of data centers as we would think of them, perhaps as Scott looks at traditional data centers. But if you think about what's going to happen, you're going to have a combination of cloud capabilities with underpinnings of big data looking for real-time analytics. The market is going to go towards this instant gratification, which we see coming down the pike. There's no stopping it. And what's going to happen is that you're going to need facilities that are either close to the power or close to the data to be able to create and answer those inquiries or those services that are going to be created. And so the data center, that's what I was hinting at earlier, the data center that we know today, that configuration might change dramatically. The other thing is that the cost of adding on a new customer is going to come down dramatically. And you're going to, your business units are going to look and say, if it's too costly to bring on a new customer using today's siloed pillars of information, then they're going to outsource it. And this is where I see an interesting development in the future, and that is that the service providers will create the data centers, and there will be brokerage through the dark fiber into enterprise data centers for either information or content or resources. And you're going to get this, and I'm trying to avoid the word hybrid cloud, but you're going to get this interaction between the service providers and the enterprises. And that is going to be this, again, a new type of very, very dynamic, flexible data center. So the answer is this is not going to be my data center or your data center tomorrow. It is probably going to be a distributed. I think, again, Mark hit it on the head. I think the small, medium enterprises or businesses are going to take advantage of those clouds and get into it, driven by those service providers. So I see this transformation coming down that's going to be a challenge to us and a great opportunity to be able to get your hands around it. I just love the idea that, as I said, I was a capacity planner, and I said to John earlier, 10, 15 years ago, I thought my job was hard, predicting the camelback hump curve, of usage. I have no idea how capacity planning is going to handle the demand from cloud. And the result of that is that how do you predict the demand in the data center? And I think that's one of the questions you probably are wrestling with right now as you go forward. But think about it. 2015, everybody is going to be connected. There's no reason why there's each of us in this room aren't talking to each other, whether we like it or not, through social media or whatnot, or through sensors. But by 2015, we think 7-point-something or odd billion devices will be able to confidently talk to each other. That's going to create a lot of content, and that content has to sit somewhere, has to be accessed somewhere, and how we get there is that nice opportunity for everybody here.
Of course, it depends who you mean by everybody, because you've got another 5 billion or so people that don't have access to the technology that we do today. So,
but those could be sensors, they could be machine-to-machine talking. I've been very generous with the word everybody. You don't have to have a heart. Oh, well. That's a bad joke. That's a bad joke for those of you who know me. But at the same time, those things will talk to each other.
So I'd like to make one comment on this topic from a smart grid perspective, and that is that underlying the move towards the cloud in data centers is the technology of virtualization and sort of decoupling of the physical data center from where the functionality has to take place, right? And that's related to one of the new paradigms that smart grid is going to bring to us. Only one of, there are several, but the one I'm talking about is that the smart grid allows the grid operators to use the demand side of usage as one of the mechanisms they use to balance supply and demand on the grid. It's critically important when you operate a grid to balance supply and demand, because otherwise you get blackouts. Historically, they've done that by modulating supply only, period. And data centers are such a huge user and becoming more of a user of the overall energy that the ability to be flexible with the usage, perhaps by virtualization of actually moving that load out of a given territory if it's constrained or has high energy prices, et cetera, is tremendously powerful. We've only seen the beginning of this in what's called the demand response marketplace in the U.S., affecting capacity markets in the U.S. But there are a lot of other possibilities. And just as an example, there have been several instances in the U.S. and in Europe in the past couple of years where, because the grid operators find it more expensive to move their supply up and down, the price of energy, particularly at night when there's a lot of nuclear and a lot of wind available, has gone negative, meaning that users will be paid to use energy in those cases. And so this is, now think about the flexibility the industry has in terms of virtualization, of being able to respond very quickly to the needs of the grid in terms of scaling up and scaling down to drive not just minimizing cost, but to drive real revenue opportunities and more reliability.
I just want to, can I add something there that, so virtualization absolutely is a good lever. The thing that I'm actually particularly interested in is the role of developers in actually helping IT folks know what's important to run when. There's a lot of stuff today that runs in data centers at, say, 3 o'clock in the afternoon when it's 120 degrees outside that really doesn't need to run right now. And if you are getting a signal from the grid through your data center operator that says, hey, by the way, now is not a good time to run, and we're going to jack the price up potentially, or now is a really good time to run and we'll pay you, that I think would definitely change the dynamic as to when we run stuff. Certainly there's a lot of stuff that, is interactive, end user driven that needs to run now, but, a vast amount of computation is done just, whenever they feel like it, because there's no incentive to actually not do it whenever you feel like it.
Catherine, I want to address your question about kind of rural or urban. I think data centers that are far afield, close to power, close to hydro or low carbon power, or close to certain types of climate, they make a lot of headlines. We all know where they all are because those economic development agencies and the customers that announce them, Microsoft in Iowa, Facebook in Prineville, Yahoo in Buffalo or the upstate New York area. I think if you took that whole kind of, and I'll just call that the rural growth over a period, say 24 months, I would argue that that probably matches about Silicon Valley's growth in that same market. So my point is that divide between urban and rural, I think, follows more traditional demographics. The rate of rural data center growth is much lower than the rate of overall data center growth. And we see this and, we scratch our heads, we think, why would anyone want to build a data center in California? In Silicon Valley, we have 50 megawatts of data centers in 10 different locations within a few kilometers of here. Zone 4 earthquake hazard, the permitting and rule sets around, the environmental risk. PG&E went bankrupt at a period, and there were rolling blackouts for business reasons. That wasn't an engineering reason. Those were business reasons California was suffering from power. Yet it's our biggest market, and it's one of the fastest growing markets. And so I think, overall, when you talk about these big systems, you look to nature, and these things are going to be organic. So I presume that compute will be distributed, but in the organic world, you've got microbes and you've got redwood trees. So I think I think it's really interesting, this idea of a little virtualized machine in my closet and the heat is warming my hot tub. Awesome, sign me up. But that doesn't mean that there's not going to be a 10 megawatt data center owned by an enterprise in the same city. So I think that hybrid growth in both cases, and I once again, it goes back to this kind of human demographics, and cities are kind of on the rise again. As these other technologies bring efficiencies to being close together, you're seeing some of this stickiness and aggregation. And I know we have incredibly low, our operating costs continue to drop, I think is the right way to say it, in these campus environments, because I swear that in our Chicago building, there's a battery technician who never even leaves the building. He's got so much work to do that we just keep feeding him takeout fast food, and he just keeps checking batteries. I mean, he literally doesn't have to leave. And the efficiencies we get from management and operations are really, really high by aggregating. I don't think you can get that scale in a rural environment.
I was kind of wondering whether you're going to give a key to your house to the person who's going to be servicing the server under your hot tub. Yeah.
Right.
So
Stephen.
Maybe I can just add some of this conversation. Is this not working? Is it on?
Yeah.
Okay. I'm not an IT guy, so I'm not going to pretend that I know exactly how these business models are going to develop. But if I was running data centers or had a company where data centers were really important to me, I would be looking at cost structure and thinking about how I want to proactively make it develop. And if there's one thing I think we'd say at RMI from our own study and the actual work and design and build of data centers is that we see an enormous opportunity to make them much more efficient. And if you knew that you could get 30% more capacity out of your existing infrastructure, and I agree with you, it's not going away fast, and you knew that you could build a data center today that's 10 times better than the best data center today in terms of energy per unit of compute or service power that you provide, you might think very hard about just allowing the market to develop what you want if you want to compete. I think the other thing is, I agree with you also around the geography. There is a natural tendency to put it where it is close to where people want. People who own and run data centers really actually like to control them and have a lot of risk aversion, totally understandable. But one of the data centers that we designed and helped build was actually located in a place where the environment allowed you to essentially eliminate mechanical chillers. That's a gigantic cost advantage over time. And I think when you start looking at analogies in other industries like the aluminum smelting industry, where the way you site a smelter in the world is you find out where there's cheap electricity, and then you put a smelter in. It doesn't matter if there's any alumina around at all, actually. And I would just say that you ought to think about what can you get out of your current capacity, and I'd say 20 to 40% more, no problem. What can you get out of your new facilities? Look for a factor of 10 to 100, depending on what your benchmark is, and think very hard about what geographies you're really going to build them out into, because I think these pipes can be put almost anywhere. And if you start thinking that way, I think because things evolve slower than the leading edge of a technology will allow it because of the bricks and mortar problem, you might find that your competitive position between now and 2025 is in part defined by what you're going to wrangle out of your current assets, how you're not going to build things for the next 5 years, which might be NPVs of hundreds of millions of dollars, and then how you're going to set a footprint that will still be viable in 2025. Because you're going to make that decision next 2, 3, 4, 5 years, not in 10 years.
So what do you put?
I'm not sure I agree, because the argument that we're describing is a very, very unified customer base that says, I know where my customer is going to be, and I know when they're going to come up and for air and ask a question that I have to fulfill that demand back in compute. But when we're very, very connected and the request comes from a mobile device or a sensor, we don't know where that request is coming from. And I worry that the notion of putting the data centers close to where the people are gives us this false sense of security.
Let me be clear, though. I wasn't saying, one, that all these things wouldn't be interconnected and there wouldn't be a cloud. And two, I'm not saying I'd put it next to where the people are. One of the ones we built is in the middle of nowhere, North England. There's no people there at all, basically. So I think it's really thinking about the energy and the economics, because ultimately you got to deliver service per unit of energy. And then to bring this back really to the RMI mission is, if you don't think the government's going to look over your shoulder and generate a bunch of legislation around CO2 emissions, if you don't think the utilities are going to come knock on your door and say, how come you're using so much peak power at 5 p.m., we're going to charge you like crazy for it. And that will lead to all these interesting swapping of data and information around the world for looking for cheap power. But you got to get down. I don't believe that the IT revolution is sweeping away fundamental economics of business, nor can it ignore things that we're pretty busy ignoring right now in the U.S., like climate change and resource constraints. No, because those are coming knocking on our door right now.
No, I mean that latency is going to kill us if we're too far away. Yeah. And if we're trying to do inquiry and respond to a big data inquiry and try to put that over the network, and that's 3,000 miles, that's I forgot what it is, it's either 3 milliseconds, 30 milliseconds added response time over the network, it's going to die. And this is where we need to be careful, and I'm just trying to get a balance between being respectful for the energy equation and being respectful to the latency equation.
Well, so isn't that is actually the real challenge, and I'm not qualified to answer it, but I can assure you that the energy and economics and the environmental consequences will be pushing against the desire to have free flow of information all places all the time right next door to you, and you can't deal with 3 milliseconds, you got to be at 100 microseconds, okay? Sure. But that's probably the real challenge for people who are going to build out these systems, because that's a real tension I don't think is going to go away anytime soon.
Quick question for Jim. What do you think is driving the growth of urban data centers in California? Is it latency or habit?
It's going to sound like a silly cliche, but it really is the whole kind of innovation enterprise around the Silicon Valley, right? There's a lot of things that drive general economic growth, and that innovation machine works at a higher rate here. The latency question you see much more around the financial capitals. And so one of my questions on this point is, for people in the IT community, do you see what's the change in balance between stateless and stateful compute, right? So virtualization, you think of, well, stateless compute is overwhelming everything. Yet at the same time, you talk about mobile devices and transactions, those are stateful transactions, and I think humanity has more and more transactions happening. So once again, it's this balance. If stateless compute and stateful compute are growing at the same rate, well, then things probably won't change too much. But I think in California, it's not latency, it's access to people and ideas and machines and relative ecosystems of the business community. Whereas you get to New York and London and Tokyo, Singapore, there's a lot more focus on latency related to financial activity.
So we have a question from the audience. Would you introduce yourself?
Yes, sure. My name is Lex Koors. I'm from Interaction Carrier Neutral Colocation. And looking at 2025, unless we invent the biochip, the demand for data will exceed the efficiencies. So if we look at Europe, we do have a kind of smart grid. We have a local grid connected to national grid, connected to international grid. We can buy chunks of green, so they invest in green stuff. And how do you see this as a panel? Because 2025, there will be a horrendous demand for power. And if you believe that you will put your data center close to a local connection, I think we're going the wrong way, because there's a horrendous inefficiency in small local grid supplies. Because you always need redundancy, overcapacity, so they will all be running inefficient. So I think we need to look at the smart grid. We need to look at 2025 from a global capacity view. What is your view on that?
Yeah, so, and you know, IDC and EMC were involved. Well, it's IDC performed the study, the digital universe, that says that data is going to grow 44x from 2010 to 2020. It grew 9x in the last 5 years. So I think we're clearly on track with this crazy growth to, and I think the number was 35 zettabytes. How do we handle that growth and capacity? And what does it mean for the people who are operating data centers?
Yeah, I think that's one of the key issues to resolve here is the sheer volume of whether it be transactions or whether it be content that's being generated by everything. From my perspective, by 2025, we're going to have to give up what we have today in terms of civil and personal, not liberties, but concerns about where the information is stored and how the information is stored. I think, to your point, to take advantage of any grid, be a smart grid, put into an intelligent grid, you're going to have to give up something. And I think that we are just, again, entering those areas of uncertainty that governments know what that means, whether the privacy laws will take advantage or oversee the energy requirements to run the economies. And I think what you're going to see is you're going to get a very competitive situation set up between the European Union, parts of Asia, that will dominate the notion that where the compute can be done because of either the energy, the collaboration of governments, and that's going to create an interesting economic challenge for everybody else. So it's not an easy one to solve. I don't know if anyone else has.
Yeah, from my perspective, I guess there's it's important to think about the problem you posed, not in the context of the way we've always managed the power grid, but in the context of what we can see as a possibility for 2025. And so I think there are three things that we need to look to address that challenge, right? One of them is virtualization. We talked about that a little bit ago, but there are other reasons why we also will have to have local capability. There's another aspect of the smart grid that's called edge power. So there's a lot of belief that a lot of the power generation is going to be distributed between renewables and other energy sources, and there will be a lot of microgrids that are interacting in an intelligent fashion in order to balance everything. And the third is what's sometimes called the holy grail of power engineering or the smart grid, which is a true economic form of energy storage. I was actually at a conference in Thailand about a month ago where someone in the industry was giving a speech, and he used that phrase, the holy grail of the smart grid. And you can see about 1,000 Buddhists had no clue what he was talking about. So anyway, one can imagine that particularly with all the research going into battery technology because of electric vehicles, et cetera, that there actually will be a viable technology in and around 2020, 2025. And it's really what will the power grid look like in that structure, in that context, to handle the problem you're talking about?
Jim, are you